Great. And then we have a couple of questions that have appeared in the chat. So let me read out the first one that I see, and then I'll hand it over to Randy. The question says, you said something earlier about students using their intuition to solve the maths question. I'm a university student and sometimes have trouble using my intuition in mathematics. How would you suggest an older student go about developing their intuition? That's from Layla.
Sure, absolutely. So I think a good example of this would be going back to calculus again. Again, it's something that I never learned when I was a young student because it was not offered at my high school. And when I went into that calculus class my first semester in college, it made absolutely no sense to me. And I left that class not even understanding what calculus is, even though I got a passing grade for it. I just knew how to find the answers, but I didn't know what it meant. So I ended up much later in life actually having to teach myself calculus. And one of the things that helped me learn it when I was older was using the same strategies that I insist my students use. Like when we're doing word problems, I insist that they include the units when they're doing their calculations, because that helps me keep track of what each of the numbers means, and it helps me spot mistakes much more easily. So to give you a specific example, let me share my document camera again. So here we go. So here in this example, this is a related rates problem in calculus. And I have two examples side by side, but one of them has a mistake in it. So we're supposed to find the rate of change of the area of the circle if the radius is growing at a rate of 3. And if you just look at this problem side by side, one of them has a mistake with them, but it's a little difficult to find out where that mistake occurred. So I'll leave it on for a few seconds so you can absorb it. But now if I take this very same problem and I put the units back in, so I'm going to put the units in, and I'm going to also color code the units. And when I do, the intuition behind the problem becomes a lot more clear, and you'll be much better able to spot the mistake. So here you can see that instead of just writing down 3 and 8, I included the units. So it's 3 meters per second and 3 centimeters per second and 8 centimeters. And when I do it this way, it becomes much more apparent where the error is. So if you take a close look, in this problem here, we're looking for an area. And I know area is presented in square units. So if you look here, this could be a reasonable answer because my final answer is in square units. But if you look on the other side, I'm looking for the area. And my final answer is not in square units, it's just in units, just centimeters. So this is not an area, this is a length. So when I do it this way, it's much more easy to spot my mistake. And I can tell that this is reasonable as an answer because it gave me an area. This is not reasonable as an answer because it's giving me a length. So by including the units in there, I can tell that something went wrong in this problem. But if I didn't include the units, it's much harder to figure out where that mistake happened. So if we go back to this example here, where did I go wrong? There's the 2 meters. The radius is 8 centimeters. Oh, I forgot to include the difference in the radius or the difference in time. So that would be the 8 centimeters here. So let me go put that in. Forgot to include the 8 centimeters. So here's 8 cent. Well, I'm sorry. I forgot to include the rate. So that is 3 centimeters per second. It's even helping me now. So that's 3 centimeters per second. Centimeters times centimeters gives you square centimeters. 2 times 8 times 3 is not 16. That should actually be 48. So let me fix that. So now I have the correct solution of 48 pi square centimeters per second. And again, if I try to solve this problem without the units in there, and left the dimensional analysis until the end of the problem, I wouldn't have been able to spot the mistake that I made. But if I do the dimensional analysis within the problem, not only does it help make sure that I get the correct units, but it helps guide me with the intuition as well. So something as simple as insisting that students include the units, not only in their final answer, but during the calculations as well, is personally something that helped me when I was self-teaching myself how to do calculus later in life.
Wow, that's something, to be honest, as a maths teacher of over 20 years, I haven't given as much insight or thought about. I've often been one of those who said, leave it out, it's easier, and plonk on the centimeters at the end or whatever they're dealing with. But that gives a whole different dimension to it.
Yeah, and absolutely. And Sean, we're being experts at math, it's so intuitive for us that we can leave the units out as educated adults because we know what we're doing. But when you think about it from a novice who's learning it for the very first time, they don't have the intuition that we do. So that's why even though we can solve the problem without including the units, for a struggling student or someone who just can't get the intuition, something as simple as that can make all the difference. And hopefully they get to the level where they can solve it as well, even if the units are not included.